this. All right, so just in case you came late, I just got to reiterate some of the announcements I said before. Basically, today we're going to be doing day 2 of energy, and it's basically going to be the fun stuff like activities and games. We're going to do some practice problems, and then also, if you didn't see my post, 3 to 4 p.m. today we have a webinar with Brian Wu on science research. So if you're interested in science research, definitely join. I posted the Zoom link there, so you guys don't have to register again on a separate form for it. Even though it's usually how it goes like that way, but since you guys are in a TCSM class, you don't have to. So definitely, if you want to join today, 3 to 4 p.m., please do so. The third thing is that we're also launching tutoring because some people have been requesting for tutoring other than like after class, which is obviously something that is a conflict because some people need help on like a test or a quiz or homework, and it's during the weekdays. So we're going to be doing tutoring Monday, starting next Monday, Monday to Thursday. So it's going to be Monday and Tuesdays are math days, and then Wednesdays and Thursdays are science days. So it's going to be 3 to 3:30 every day from Monday to Thursday. The Zoom link is on our website, so it's open source. You don't need to register for it. And again, if you haven't, it's going to be math is going to be from first grade math all the way to pre-calc, and then for science, it's going to be from first grade science all the way to New York region level curriculum. And we're also trying to launch like AP Bio, AP Chem tutoring, or AP Psych. But I'll be doing AP Physics 1 for sure on Wednesdays 3 to 3:30. So I will only be able to go on Wednesdays 3 to 3:30. So if you have any questions related to AP Physics or you want me to help you specifically, we're gonna have other people help you out. But like if you want me to help you specifically, you have to, or AP Physics 1 specifically, right? You have to join on Wednesdays 3 to 3:30, or otherwise I won't be able to help you like on Zoom, and you probably have to just email it to me or post in the Google Classroom, which is going to take more time, obviously. So yeah, that's basically all the announcements. And if you have any siblings or friends or families, or other parents who like are asking about any tutoring services, things like that, you should definitely let them know. Again, everything that we're doing is for free, and the people that are going to be tutoring is they've taken the test before and they scored exceptionally high, or they had like high GPAs in their classes, so they know what they're doing. All right. So yeah, that's basically all the announcements I have to make, and so let's get started. So actually, the first thing I wanted to do was just do a little review on like what we learned last week, because I know some people definitely it has been 1 week. I know you guys all have school and like you probably forgot everything. So we're just gonna go back into time. Basically, first um the first slides on work, right? Energy, open and closed systems, things like that. We're gonna go through this really quick, and then we'll do the quizzes after. So quizzes is kind of like Kahoot, except I've been playing around with it, and I think quizzes is a lot funner because you can get power-ups. I think there's like Jeopardy or like double or nothing. It's like basically you get bonus points if you get double the points if you get the question right, but you get half the points if um you get it wrong. So it's like double or nothing. And there's also like immunity, which is basically you get a redemption to if you got one question wrong, you can redo it. Basically, there's a bunch of power ups. I think it's much funner, and um, it's kind of like a hoot. Like the faster you answer the question, the more points you get, and it's kind of like it's basically the same thing. You just input a code. I'll send you a link. Just press on it, and you don't have to make an account, so you can just join. And it'll be relatively fast. We'll do like 2 of those, and then afterwards we'll do some practice problems. And then if you guys have any questions, you can let me know. And again, all the hands-on stuff like the labs we're going to do after we learn everything. So right now, then our next unit is going to be momentum. So this is energy. Next year is going to be next unit is going to be momentum. All right. So just to review really fast, right? We talked about potential energy. We have 2 types of potential energy specifically when we're talking about mechanics. That's spring potential energy and gravitational potential energy. And we use to find spring potential energy, we use the equation 1/2 kx squared. K is the spring constant and x is the displacement of the spring. The equation that we use for gravitational potential energy is equal to mgh, M is the mass in kilograms, G is the gravitational field strength in meters per second squared, and H is the height in meters. All right. Then we talked about kinetic energy, right? Linear and rotational. Unfortunately, we're not going to deal with rotational yet, but we're going to in the future. And it's basically for kinetic energy, linear, we use the equation 1/2 mv squared. So we know 1/2 obviously is the constant, m is the mass in kilograms, velocity is v in meters per second. All right, so let's move on. Clear this. And then we also talked about conservation of energy, right? Energy can only be created, energy cannot be created or destroyed. It can only be altered from one form to another. So remember we talked about, like, let's say there's a car, right? You fill up with gasoline, and the car itself is not moving. So it does not have kinetic energy because velocity equals 0, but because it has gasoline, gasoline itself is a form of chemical energy. And when you convert chemical energy into kinetic energy, your energy is still the same amount, right? It's still in that same amount of joules, but it's changing from one form to another. So it's changing from chemical to kinetic energy, right? When you press the gas pedal, the engine heats up the gasoline, kind of like a steam engine. It converts that heat energy into actually mechanical energy, which is something that you could use to move something or generate power or stuff like that, right? So next, we also talked about what is total mechanical energy. Total mechanical energy is basically the term we use for the sum of all the energies within the system. And that is within the first initial state and in the final state. So we have a total mechanical energy initial, and we also have a final total mechanical energy. And the reason why we use mechanical energy is because we're dealing with mechanics, right? We're not talking about electrostatics or electricity at the moment, right? Electric potential energy, we're not dealing with that. We're just dealing with mechanics, things that we can see and that we can use, like if I push something, right? That's obviously giving that object energy. Adding energy into that system, right? And also, right, you can, and also for systems to be conserved, we also talked about energy cannot be taken away, right? It has to be conserved. And the ways, some examples that you could have a conserved system is obviously no friction, or it's completely isolated. So within the system, there is no friction, right? No energy is being taken away. Obviously, friction does exist. So let's say I have a box right here, and I'm pushing it along a sandpaper surface, right? Constant energy is being taken away from that box system due to friction, right? And we don't just say energy is taken by friction. We say energy is taken away by the work due to friction, right? Because you can't just say, oh, I'm going to take energy and minus the force of friction, and there you go. You can't do joules minus newtons, right? You have to do joules minus joules, which is why you use work. So work is force times distance. So in that case, you would just do force of friction times distance you push that box, and that would give you the answers in joules. Then you would take the initial total mechanical energy, right? And you would subtract it by the work due to friction, because friction does take away energy. I don't even think a system exists where friction could add energy into a system. It's usually taking away energy. So that's an example, right? So then we also talked about work, right? Work is basically force times distance. To be specific, is actually displacement, right? And work is a scalar quantity, and its units are in joules. And remember, the force has to be in the same direction as the displacement. You cannot have a perpendicular force to a perpendicular distance. It will not work. Just like how the lady right in the picture, she's carrying a pillow, a really, really heavy sack or something. She's walking forward, but she's applying a normal force upwards. So her force and this displacement, direction of displacement, is not equal. They're not parallel. Even it doesn't have to be necessarily parallel, but it should be in the same direction. It should be like a vector at an angle between 0 and 90. So obviously in this, the top picture, you have an angle of 90 degrees. That's obviously greater than 90. It has to be, let me just reiterate this. The angle has to be between 0, let's just use theta, right, and 90. it's not equal to or less than. It's just less than. So it does not include 90. The reason why, right? You see at the top, the lady is carrying this sack, right, and she's moving forward. That degree is 90. It's like a right angle like that, right? So that's not within this range. So it has to be within this range in order to do work. That's why if you see the bottom, basically the bottom image, right? This theta is obviously less than 90, right? And that's why it's doing work, because you can calculate the x force, right? Because force is a vector, so there's always an x and a y component to that force. So if there's an x component to that force, and you know that the theta is at less than 90, then it's obviously doing work, right? You wouldn't do force applied times distance. You would do F cosine theta, which is the x component of that force, times the displacement, because F cosine theta is in this direction, displacement is also in this direction, so they're parallel, right? You can't do it this force and the displacement is in this direction, right? That's not, they'll intersect, so it wouldn't work. It has to be parallel. All right, so that's a quick overview. Let's move on. So then we also talked about power, right? Obviously, when we talk about power in physics, it's not Thanos, right, with the power of all the 6 infinity stones. Wait, I think it's 5, yeah. Wait, 6? Yeah, 6 infinity stones, yeah. Obviously, right, that's not what we're talking about, though it could be true. And power is basically work over time. Power, you could think of it as acceleration, right? Acceleration is velocity over time, change in velocity over time. Power is kind of like change in work over time. And then we also know that work equals force times displacement, as we said before in the previous slide. So if we just break that out, expand it to force times displacement, we also know that displacement times over time is velocity. So then therefore we could say power is equal to force times velocity. And that's the same thing, right, that we can do with work, right? With work, we know that it's force times displacement. We know that force equals ma from Newton's second law. So we could say MAD, which is just mad work, right? When I say you're doing work, you just say mad. Yeah, you could try to fool your physics teacher if you wanted to, like act smart or something. I don't know, but yeah. So then the units for power is watts. So it's basically when you do force times velocity, which is newtons times meters per second, you get watts. So watts is like a derived unit. It's derived from newtons times meters per second. Again, power is a scalar quantity, and it's basically the rate at which work is done over time. You can, if you don't want to think of it in like a physics kind of scenario, you could think of it as like how strong is something. Like if I say you have like a drill, right, and it's like a 19-volt driller compared to like a 17-volt driller, the 19-volt is stronger is because at every second it could use up more energy than the 17-volt. It's kind of like, you kind of think of it as like batteries, like a 9-volt battery and like 2 AA batteries, right? The 9-volt batteries, obviously it's bigger, right? It's bigger than an AA battery, but that doesn't really relate to anything. But basically, the 9-volt battery is releasing more energy at one time compared to the 2 AA batteries. That's why usually if you have like a car battery, it has a higher voltage than like a computer. Than a phone battery, right? Because a car battery has to use up more energy per second compared to a phone, right? Because it has to generate and start up the entire system. So it's kind of like power. Power is kind of like the amount of force you use. I'm sorry, the amount of work you use per second. Okay, so the more work you're able to use, that means the more power you have. So power in this scenario, we're not talking about electrostatics. I talked about voltage, but like it's not part of that. It's more of like mechanics. So if I was describing a horse's power, right, we use the unit horsepower, but if I was describing how powerful this person was, I would basically measure his work over his time. So how much work he can do over a period of time. And you would actually find out that usually heavier people they have more power compared to a lighter person, like someone that has less mass. Okay, so power, obviously, I didn't see it come up in the AP Physics 1 test last year, like when I was taking it, but it's definitely, you should keep it in mind if it does come up. Yeah, but definitely when you're dealing with energy, you want to be very solid on with potential and kinetic energy. Those are the two main things you're gonna have to deal with, as well as work. Power, I've rarely seen it, but you might want to, just in case it does pop up. So then we also talked about forms of energy, right? We can have work due to friction, sound, heat, chemical, and mechanical energy, right? And these are all just different ways where um, energy can be taken away or added to the system. Okay, I think that's it. Yeah, so let's go on quizzes right now. If you can, just get a piece of paper as usual. um, paper, obviously pen or pencil, any writing utensil. Get a phone or tablet or use computer, split screen it. Um, and the good thing about quizzes is that you don't need to see my screen. You can see your own screen. It will not. You don't have to look at my screen to see the question. It will show up on your side. Okay. So that's a good thing. Unfortunately, I will be competing with you guys to make it more competitive. I will basically, I will answer my question 10 seconds after it starts. So that gives you guys a head start. So like, it's not like a GG, like a default GG for you guys. You guys do have the chance to win. But I'll be competing as well. All right. So, and obviously I'll input my answer 10 seconds after. So we're gonna do like kind of like a run first. There's also power-ups. So, um, I think every third question or fifth question, they give you a power-up and you could basically activate it or not. Different power-ups have different uses. So you can have like immunity, which is basically, helps you, it's like a redemption question. So if you get it wrong, you can answer it again and get the same points. There's also one called, um, there's like legendary, I mean there's like rare power-ups and there's like common power-ups. There's also one that like does 50-50, which is basically it eliminates half of the answers for you, so you just have to select between two instead of four. You also have, I think one more is like it eliminates one answer choice for you, so like instead of answering four you get three, but those are like the common ones. All right, so let's get this started. All right, do you guys see my screen with quizzes?
Yes.
All right, so yeah, you guys can join. I'll also share the direct link in the chat. Have you guys played quizzes before? Just let me know from
Yes.
yourself. Yeah. How about the rest of you guys? Other than Anna. Yeah. Yeah. In school or like by yourself? Oh, okay. That's nice. That's nice. So yeah, I think you guys probably know how to use it. Still waiting on one person. Um. Okay, let me just double check the name. So it's Jason for one. Yeah. Okay. Tom. Jason. Xiang. Wait, who's Dorana? Is Dorana? Is that your name? Did I pronounce it right? Okay. Are you gonna join? Like, just let me know if you're still having problems with the joining, so I can wait for you. Okay, you can't join right now. So do you want me to just start now, or you can do the next one, or like you want to join but you can't join right now? Oh, okay. If we wait 1 minute or 1 minute, will it go back or? Can you access it on your phone? Oh, I see. Wait, so you're using your Zoom on your phone right now, so you can't access it? Okay, okay. Um, okay, so do you want me to just start without you or like wait a couple more minutes for you to get everything settled? We're gonna do like 2 quizzes, so it's not. Okay. Okay then. Um, so yeah, let's get started. Wait, so if I share my screen, you guys can see my answers, right? Technically, I mean theoretically. So I probably have to stop share. Actually, fine. I'll just share screen because Dorana has to look through. But yeah, we all get different questions in different orders. So like, yeah. Oh, also just to say, there's one question that's wrong. I can't change it, but the answer is 206. 200. Wait, let me just check. Oh, it's two. The correct answer, if you have a question with a car on like a flat surface and it goes down and asks you change in potential energy, the actual answer is 117,600 joules. But quizzes, I don't know why the person who made it put the correct answer is 294,400 joules. So like if you see the question, just put 294,400 joules, even though it's wrong. So you get the points. Oh wow, someone got the power up. Nice. Thanks, Nina. Everyone is getting more points now.
Wait, sorry, what was the question you said that had like the wrong answer?
It's the image with the car is 600 kilograms, and it asks you what's the change in potential energy. It's like a yellow picture, and it's like the car's on the high surface, then it goes down like a slant, and then it sticks to another lower surface and it's flat.
What are we supposed to put? Sorry.
294,400 joules. Yeah, that question got
Okay.
screwed up. Yeah, I couldn't change it, that's why. Okay, I actually have to start putting it quicker, so I'm gonna eliminate the time frame to 5 seconds because I'm like really behind you guys, so I'm gonna just saying, all right. How is it? The quizzes? I mean, congratulations to Xiang. He got first place. Wait, did it? Oh, yeah. Okay, never mind. Okay, yeah, congratulations to Xiang. He got first place, and then wait. Is Xiang a girl name or a boy name? Sorry, I don't wanna say your name wrong. Okay. Because like there's like some Chinese names that yeah, I'm not really familiar with, but yeah. Okay, yeah, congratulations to Xiang getting first place. Me for getting second. Uh, Anna. Oh, Anna's actually. Oh, Anna might get second place. She's really close. Yeah, actually, I'm gonna leave that for later. Oh wait, never mind. Oh yeah. So first place was Xiang. Second place was me, and third place was Anna. So congratulations to you guys, and also good job to everyone who also tried. Especially like Jason, you were really close. It's just you got some wrong, and also it also depends on how you use your power-ups, I think, because you want to use it when you actually need it. So that's also how people get more points. So do you guys want to go over like what you got wrong and like use this time to go over everything, or you want to like just do another quizzes and then start the practice questions? Or you just want to skip to practice questions? Like don't even do another quizzes. Just let me know in the chat what do you guys want to do. Wait, do you guys hear me? Like my audio? Because I don't know if sometimes there's like Zoom issues with my audio.
Sorry, what were the options again?
Okay. So yeah, the first option is go over this quizzes, like what you got wrong, and then we can go over together. Or the second option is we can do another quizzes. And third option is just skip the quizzes and just jump to practice questions. Because we have around 20 minutes left. Oh, okay, yeah. So I got one vote from Xiang for going over the quizzes. Anyone else? Majority wins. Okay, I have one for practice problems. Go over. So 2 for go over. Anyone else? We still have 5 people. Still need an answer from Jason and Nina. Okay, I got another go over. Okay, sorry, Anna. We have to go over first. So, we're gonna go to practice problems, but we're gonna do that after we go over. All right. So, do you guys see my screen on the quizzes? Just give me a yes or no. Yeah. All right. So which question do you guys want to start off with? From my screen, not from your screen. 3. Okay. So the 65 kilogram skydiver, right? 3. Okay, another 3. All right. So how about you guys? Just tell me where you got stuck on. So like, what did you do first, and then what did you get stuck on? Because like sometimes when I'm solving the problems, I don't think it's really helping you guys because you're just looking at how I did it. But if you guys fix your own mistakes, that's probably more beneficial for you guys. So just tell me, what do you guys do first? Just put in the chat. What do you guys do first? Oh, and you guys can unmute. You don't have to type everything to the chat. I think it's easier if you just unmute yourself. Yeah, so it's kinetic energy. So when you see kinetic energy, that's 1/2 mv squared. All right, so I'm just gonna, since you guys don't want to talk, I'll just be the person talking. But I would really appreciate if you guys could talk, because it's kind of, if I'm the only person talking, it's kind of boring. But anyways, yeah. So you have a 65-kilogram skydiver, jumps from a plane. Her speed steadily increases until air resistance provides a force that balances the force due to free fall, right? Okay, so there's something called terminal velocity. You don't have to know this for AP Physics 1, but it's basically when you have, like, let's say a disk, right? It's going down with FG, and there's basically a point where air resistance becomes the equal in magnitude force to FG. So it'd be FAR. So at one point in time, your air resistance is equal to your FG. So if your if your air resistance force is equal to your FG, what happens in terms of velocity and acceleration?
Is it like the fastest you can go or something?
Yeah, but like in terms of velocity and acceleration, what happens to acceleration and velocity?
Are they constant?
What's constant? Acceleration or velocity? So assuming this is the positive direction, this is the negative direction. I know what it was on the right track, but I needed a more specific answer. Like, what do you think happens when you have a ball, right? And you just sometimes when you go skydiving, you expand your area and you basically go flying down with with an acceleration due to gravity. But at one point, your air resistance balances out your force of gravity. So what happens? Think of Newton's second law when we said that net force F equals ma. And we just said that FG is equal to negative FAR. So that means that they're equal in magnitude, but opposite in direction. So if you have, let's say FG equals 3 newtons, and FAR is negative 3 newtons, what happens when you put that into Newton's second law? You could put your answer in the chat. So I have FG, right? And I'm adding that with a negative FAR. And we know that FG is equal to negative FAR. So what is this equal to? You can just put in the chat or unmute yourself. Think about net force. Remember when we talked?
Oh,
Yeah, go ahead.
is it 0?
Yeah, it's 0, right? The reason why is because they're equal in magnitude, but they're opposite in direction. You see this? See the negative sign and the positive? There's like an imaginary positive right here. They're equal in magnitude because of this, but they're opposite in direction. Because they're opposite in direction, they cancel out each other. So you get 0. Now we know that F equals ma, right? So if your net force is equal to 0, what is true about your acceleration and your mass? And I mean, what is true about your acceleration? Your mass can't be 0, or else that wouldn't work. What's true about your acceleration? Just put in the chat or unmute yourself.
acceleration was equal 0.
Yeah, right? Acceleration is also equal to 0. You can't have a mass equal to 0, because if your mass was 0, you wouldn't be in free fall, because you have no mass. You're like a non-existing particle, and you're just floating in the atmosphere. You're not even particles in our atmosphere have mass, but they're super small. They're almost 0, but they still have mass. I don't even think anything that without mass has anything that has a mass of 0 has an acceleration. It doesn't. Um, I think light also has a mass. I'm not sure, but to my knowledge, I don't know anything that does not have mass. Okay, anything has mass. Okay, so if you're mass, you have a mass, right? You know that x times y, right? If x times y equals 0, either x is 0 or y is 0. And because mass is not equal to 0, you can therefore say that acceleration equals 0. So if your acceleration is equal to 0, what is true about your velocity? I would just write this out. Acceleration equals change in velocity over time. So if your acceleration is equal to 0, what is true about your change in velocity?
Well, velocity will have to be constant, and I guess in this case, it might have to be 0.
Yeah, right? Because you can't have time equals 0. If you have delta v over 0, that's undefined. You can't have anything over 0 that's undefined, so there's no answer. So that means that, right? And you can't even have 0 time. If you have 0 time, you're literally saying like an object falls 3 meters per second squared, but then you don't give a time variable. So that's like non-existing. So it has to be changing in velocity over time. But because you know that this over this equals to 0, and your change in velocity is just, right, vf minus vy, that means you have no change in velocity. That means your velocity is constant, because there's no change in velocity. Okay, and that's where you get something called terminal velocity, which is basically when your object is just falling at a constant velocity. It's no acceleration is equal to 0, but that velocity is like really high. So it's like almost you're falling really fast, but you have no acceleration. This is basically what the problem is saying, right? When it has, until air resistance provides a force that balances the force due to free fall. Basically, force of gravity is equal, the force of air resistance balances the force of gravity. So how fast is this skydiver falling if her kinetic energy at the moment is 704,000? So this is, right, we know that Ke, right, equals 1/2 mv squared, right? They give you the mass. Mass equals 65 kilograms. So the only thing you have to do is transpose everything onto the left side and square root that to find your velocity. So it should be Ke should be 2Ke over m square rooted. That gives you a velocity. So you just input your answer. Your Ke is 704,000 joules. Your mass is 65 kilograms. Does that solve the problem? Just give me a thumbs up, or actually I can't do that with my Zoom, unfortunately. Just let me know in the chat, yes or no. That makes sense. Okay, so what's the other question you guys want to go over? Is that the only one, or you guys want to jump to practice problem? The 40 kilogram box one. Let me see, what's the 40 kilogram box? Yeah, no problem. This one, 21. All right. So The problem says a 40 kilogram box is picked up by a crane to a height of 50 meters. So you could basically draw, right? You know that it starts off at ground zero, right? This is y equals 0. This is really bad y, but this is equal to 0 meters. And it gets picked up to a height of 50 meters. So this is the original position. And then it goes up to this position. And this position is equal to 50 meters. We know that the mass is equal to 40 kilograms. What is the velocity of the crate just before it hits the ground? Okay, so this is an energy conservation problem. Okay, I'll show you in a bit what I mean about that. So let me just stop. Move this over. Okay, so we know that MEI is equal to MEF, right? Total mechanical energy in the initial is equal to final, because it doesn't say energy is added or taken away from the system. Now, at the initial state, you have potential energy because the crane lifts the box up to 50 meters. So its initial position is at 50 meters. So if it's at 50 meters, we know that there's potential energy because we know mgh equals potential energy and h is the height. So we can therefore say that mgh is equal to the MEF. But the MEF is the point, the instant where the box is about to hit the ground, right? That question asks, what is the velocity of the crate just before it hits the ground? So when it says velocity, you know that you're dealing with kinetic energy. And there's also MEF is equal to kinetic energy because the moment it's about to hit the ground, the H is 0. So it doesn't have potential energy. So the only thing that it has is kinetic. And we know that kinetic energy is equal to 1/2 mv squared, right? And it's acting about velocity. So this is something that we need to find. Now you see mass on both sides, so you can cancel that out. You don't even need mass, even though it tells you 40 kilograms. And then you just transpose everything. So you just put times 2 on both sides, you get 2g h, and you square root this. This gives you velocity. This is something that we even use, like, this is like a equation that we use for problems like this. Does that make sense? So just do 2 times 9.81 times 50, and you square root that. All right, any other questions? You want me to keep scrolling, or? Yeah, this is basically the end. It was 25 questions. Any questions? I really want to go to the practice problems because that's the one that is harder than these and more important. Okay, so if there's no questions, I'm going to go back to my slides. Just clear this really quick. And then present. So here, this is one question. I would like you guys, just try it out. Obviously it's challenging, but see if you can try to solve it. And remember, it's an energy problem. So you want to start off with energy, right? Even ask you, what is the kinetic energy of the ball at the highest point of its motion? So why don't we just give just 1 minute for you guys to just draw everything out, set up your equations, everything, and then just put in the chat, how do you think you would solve this problem? Like step by step, how would you try to solve it? Or which way would you try to tackle this problem with? Okay, so can you guys just put in the chat or in yourself, how would you try to solve this problem?
So to start with, I feel like we have to, since we're dealing with energy, I guess, and we want to find kinetic energy, I feel like we need to break up the the since it's thrown at an angle, we need to break it up into its horizontal and vertical components because we
Mm-hmm.
want it to go in the same direction that we're throwing at it. So we need the vertical velocity, I think.
Okay. Yeah, so that's actually absolutely true. The way I would try to solve it is I would draw it out. That's probably my best strategy. I would draw it out and see how it works. Okay, let me just draw this line so it's blue. So you have a thrower, right? The speed, right? And so you could draw this out like this, right? This is the arrow, and this is the ball. Let me see if I can do this better. This is the ball, right? And it's being thrown at a velocity v I, because it's initial velocity, right? This is equal to 69 meters per second, right? And we also know that this angle right here, which is very important, this theta is equal to 39.5 degrees. Okay, so we can see that if it's an angle, we're definitely dealing with kinematics right here. So this is like a projectile motion problem with energy involved. All right, so it says, what is the kinetic energy of the ball at the highest point of its motion? So what do we know about a projectile at its highest point in motion? Just put in the chat or something. What is true about the x and y velocities? X and y components of the velocity at its highest point.
This velocity final in the y direction equals 0. Well, the angle or something.
Yeah, so your velocity in the y direction, I know I didn't really cover this in kinematics. I'm not really sure, but in this scenario, right, at the highest point of a projectile, let me just put this out, right? It's Vy is equal to 0 meters per second. Because at that very instant, if you could think of it, if I'm throwing a ball into the air, right, it's going to come down at one point. But the point at which it achieves its maximum height is when the velocity is 0. Because if the velocity was not 0, if it was positive, it would still go up, and then it would eventually come down. But there has to be a turning point between going up and coming down, and that's when the velocity y equals 0. And that turning point is at its maximum peak, right? You wouldn't say that its turning point is like 5 seconds after I throw it, but it comes down in 20 seconds. That means that the turning point was when I threw it, and then it takes more time to come back down, right? The time it takes for you to throw something up and come back down has to be equal to each other. Like if I throw it up to its highest peak, that time has to be equal to the time it takes to come back down. This is true if the acceleration is constant, meaning we don't include air resistance, which is what you're going to be dealing with AP physics. If you include air resistance, it's a different story. But in this scenario, in a perfect atmosphere with no air resistance, no atmosphere, like a vacuum, then this would be true. So the time it takes to go up would be the same amount of time it takes to come down. And the turning point where it comes down, when it goes up and comes down, is at its highest peak. And we know that because the velocity in the y direction equals 0. So remember when we talked about vectors and vector additions and components, basically we have an x, right, and a y positions. The y position at this point is 0, but it doesn't mean that it doesn't move forward. It's still moving forward, but it's not moving up or down at that instant. So like at this very instant, t over 2. We use t over 2 because this would be t, the time it takes for the entire projectile. This would be the actual t. Okay. So yeah, that's true. How about the x component of velocity? What's true about the x component of velocity at the highest peak?
It's the horizontal component of like the velocity at which you threw it at.
Yeah, so it's constant, meaning it
Yes.
doesn't change. And this is true throughout the entire trip. and assuming no air resistance again, if you're throwing a ball throughout the entire trip, its velocity is in the x direction is constant. The only thing that's changing is Vy because you have acceleration due to gravity. You don't have an acceleration in the x direction because gravity doesn't exist horizontally, it exists vertically. Unless you have air resistance, right? Air resistance would change that Vx, but because we don't include air resistance, Vx is constant. So Vx is always constant throughout the entire projectile motion. But the only thing that's changing is the Vy, and because of gravity, right? Gravity is pointed towards the center of the planet. And because we're dealing with such a small problem, we can assume that it's basically downwards, going downwards, right? So that's basically what it would happen. So at its highest point, and we know that Ke is equal to what? Is equal to 1/2 mv squared, right? But what is the velocity at its highest point?
It's just Vx.
Yeah, it's just Vx because you don't have Vy. So I mean, you do have a V, like you still have the 69 meters per second, but it's not the full 69 meters per second because that 69 meters per second was thrown at an angle of 39.5. So if it's thrown at an angle, you know it has an x and y, unless it was thrown horizontally, like perfectly horizontally or perfectly vertically. So it would be velocity is equal at highest point equals Vx. Okay. So in order to solve this problem, you would then do Ke equals 1/2 your mass, which is 1.1 kilograms, times your Vx squared. But how do you find your Vx squared? Think about using sine, cosine, and tangent. If I give you the angle, which is 39.5, and I want to find the Vx, which is this, the Vx, this is Vx, the x component of velocity, and this is the Vy. How would you find the Vx using sine, cosine, and tangent? Just put in the chat. What do you think? I'm just writing out the trigonometric identities. So just put in the chat or mute yourself, please.
Okay, so you would use cosine, I think, and basically multiply 69 times cosine of 39.5 to get Vx.
You want to explain how you got that?
Oh yes. Okay, so basically cosine is equal to adjacent over hypotenuse. So your adjacent value will be Bx over 69. So if you want to find Bx, you have to basically multiply h times cosine of theta, and that will give you your adjacent side, which is Vx. And when you do that, you get I believe 53.24 meters per second.
Yeah, so exactly what Anna said. You know that cosine equals adjacent over hypotenuse. Your adjacent is Vx. Your hypotenuse is 69 meters per second. So you know theta is equal to 39.5 degrees. So you would just do cosine 39.5 times 69, which will give you Vx. And Vx would be equal to, let me just check with my calculator. It would be cosine 39.5 times 69. That gives you 53.24. Do you guys all get that? Just let me know. 53.24 meters per second. Yeah. How about Xiang and Tom? Yeah. Okay. So, and remember, velocity has a direction, right? So it has to be positive. We can't say negative. Negative would be going the opposite way. So usually when we deal with projectile motion, right is positive, up is positive, left is negative, down is negative. Okay, that's usually how we do it, the coordinates. So now we would plug this in to right here, right? We just came up with this equation. So if you just do that right now, what would you get as your kinetic energy final answer?
I got choice A.
Okay, so 1, 5. How about everyone else? What do you guys get? You guys all get 1573.27 joules? Xiang and Tom? Yeah, you got 8? Yeah, okay. So let's check our answer. So I'm gonna clear all drawings and let's see what we got. Yeah, so the answer is 8, right? And this is basically an explanation again of how you would solve the problem. Usually when you solve a problem, you want to list out the givens. Before the drawing I just made was kind of extra because I was explaining projectile motion, but you don't have to do that if you already know everything. You just list it out and then just this one is kind of straightforward. Just plug it into 1/2 mv squared, but obviously there's more complex problems. So this is kind of an example of how you would link kinematics with energy. So same thing, you could do that with dynamics and kinematics. You could literally have kinematics with dynamics, kinematics with energy, energy with dynamics, energy with kinematics, or you could have a kinematics, dynamics, and energy. So you just link all three together, and you would basically do it with projectile motion, Newton's forces, and then energy, potential, and kinetic. So it's 2:09. It's 10 minutes after, so I don't want to keep you guys, like extra time. There's actually 2 more questions. I'll attach the slides to the Google Classroom so you guys could practice on your own. There's another question here, and then there's another question here. So there's 2 extra ones. I'll also see if I can post my question problems, my P set from last year, and see if I can share that with you guys. All right, so that's basically it. And if you have any questions, you can stay. If you don't, you guys can go now. And again, there's a webinar today at 3 to 4 on science research. So if you guys are interested in doing it, I put the link in the Google Classroom so you can join. All right. Yeah, no problem. Anna, do you have any questions?
No.
Okay. Okay. Are you going to tutoring?
To like Wednesday and Thursday.
I can only be there. I can only make it to Wednesdays 3 to 3:30.